Okay, we are back again. So, although previous one also load following, but this is another version, right, another type of modeling. So, load following, I told you what is load following, right. So, when load disturbance is there, generation will chase the load such that generation will match the load in other way, right, and a steady state ideal condition. So, generation is equal to load plus of course, losses are there, but we do not consider that, right. So, in this just now we have seen that in restructured environment, the generation companies, that is GENCOs, supply power to various distribution companies, in short we call DISCOs, right, at competitive prices. Now, thus DISCOs may or may not have contacts with the GENCOs in their own area, I told you, because they have freedom to choose the GENCOs of other areas too. For the sake of clarity, consider a two area system as shown in figure 1. Here what we are our modeling is same, but what we are trying to make it, suppose in area 1 it is DISCO 1 and it is DISCO 2, right, and in area 2 this is DISCO 3 and DISCO 4, that is your distribution companies. Now, area 1 generation company is there GENCO 1, but it has 2 units, 2 generating units, unit 1 and unit 2. Philosophy remains same. In the previous case we saw GENCO 1 and GENCO 2, and assuming that one generating units or its equivalent, right. So, question or maybe many units are there with same rating, same turbine generating unit, everything, right. So, but here philosophy remains same, everything is same, but this GENCO 1, but generation company 1 has 2 units, unit 1 and unit 2. Similarly, GENCO 2, it has 2 units, unit 2, unit 3 and unit 4, and this is that your scheduled tie line power flow, that is delta P tie your 1 2, right. Same as before, only mathematically or block diagram wise slightly we have changed, right. So, this is schematic representation of a two area interconnected system in restructured environment, right. So, in area 1, now there is one generation company designated by GENCO 1 with 2 generating units, it is unit 1 and unit 2, and 2 distribution companies designated by DISCO 1 and DISCO 2, right. Similarly, in area 2 there is only one generation companies, I have missed one, right, there is only one generation company GENCO 2 and 2 distribution companies designated by DISCO 3 and DISCO 4. So, GENCO 2 also got 2 generating units, unit 3 and unit 4. So, we define the DISCO participation matrix, it will remain same, as before, right. So, this is the DISCO participation matrix. So, there we are writing GENCO 1, this is your I am making in short DISCO 1, DISCO 2, DISCO 3, DISCO 4 distribution companies, I am making it D1, D2, DT 3, 4. So, this is D1, this is D2, this is D3 and this is D4, and there it was GENCO 1, GENCO 2, GENCO 3, GENCO 4, and here instead of that we write it is unit 1, this is unit 2, this is unit 3 and this is your unit 4, right. So, this way, right, instead of GENCO 1, GENCO 2, GENCO 3, GENCO 4, we are writing unit 1, unit 2, unit 3 and unit 4, and philosophy remains same, that is your same contact participation factor, that matrix, and this side will be, if you want to find out the contact demand, this side will be same as before, delta PL1, delta PL2, delta PL3, delta PL4. So, contact participation your what you call demand for GENCO unit 1, unit 2 and unit 3 and unit 4 will be CPF 11 delta PL1 plus CPF 12 delta PL2 plus CPF 13 delta PL3 plus CPF 14 delta PL4 and so on, right. So, meaning is same, that actually actual essence remains same, right. So, this is equation 1. Equation 1, CPFs are the contact participation factor, that we know. In DPM, the number of rows equal to the number of generating units, right, that is unit 1, unit 2 of GENCO 1 and unit 3, unit 4 of GENCO 2, that I told you, while the number of columns is equal to the number of DISCOs, that is DISCO 1, DISCO 2, DISCO 3 and DISCO 4, right. So, each entry in this matrix represents the fraction of the total load contacted by DISCO towards a generating unit of GENCO 1 or GENCO 2. This already we have discussed, right. But still, for example, CPF 23 is the fraction of the total load contacted by DISCO 3 from unit 2 of GENCO 1 in area 1. This is the meaning here, right. There it was GENCO 1, GENCO 2, GENCO 3. This is from the unit 2 of GENCO 1 in area 1, that is CPF 23, right. This is the just difference. So, the sum of all the entries in a column that we have seen, that is 1, because I is equal to 1 to n is equal to unit means the number of your generating units. So, CPF ij is equal to 1.0 and j is equal to 1 to number of discos. So, n disco, right. Here it is 4, because 4 distribution components are there together, area 1 2, area 2 2, right. So, therefore, the expression for contracted power of generating units with discos given as delta PGCI, it is same as delta PI as before. Previously, we have taken that delta PI, right. It is same as your delta PGCI, the contracted power demand. J is equal to your n disco and it is CPF ij delta PLJ, I is equal to 1 to n unit, right. There we are writing I is equal to 1 T, that in GENCO, but here we are writing 1 to n unit, total number of units. So, here it is I is equal to 1, 2, 3 and 4, right. So, there where delta PGCI is the contracted power of I generating unit and delta PLJ total demand of disco J, that distribution company J, right. CPF ij contract participation factor, right. So, same as before, the schedule steady state power flow on the tie line is given as, it is same as before, the demand of discos in area 2 from the generating units in area 1 minus demand of discos in area 1 from the generating units in area 2, and it is 1 to schedule. By chance whatever data you have taken, by chance the delta P 1 to schedule become negative, say minus 0.2, that means basically power is flowing from 2 to 1, right. So, that is the actual direction. So, this is we have also seen. Therefore, delta P 1 to schedule same as before, that sigma I is equal to 1 to 2, j is equal to 3 to 4, CPF ij delta PLJ minus sigma I is equal to 3 to 4, sigma j is equal to 1 to 2, CPF ij delta PLJ. This is equation 4. This equation already we have seen for 2 GENCOs, 2 discos in each area for 2 area system, right. So, same equation, and the tie line power error also defined as delta P 1 to actual minus delta P 1 to schedule, right. So, at the steady state delta P 1 to error will be vanished. So, in that case at steady state delta P 1 to actual is equal to delta P 1 to schedule, that also we have seen, right. Now, changes will come. So, this error signal is used to generate the respective area control error AC signal as in the traditional scenarios, that is AC 1 is equal to your B 1 delta F 1 plus delta P 1 to error, and similarly AC 2 will be B 2 delta F 2 plus A 1 to delta P 1 to error. This is equation 7, right. Now, figure 2 shows the block diagram representation. First I will come to the block diagram, then all this explanation, right. So, let me reduce the volume, reduce the size, because I have to accommodate all this, right. So, first area 1 and area 2, just hold on, it is accommodated, right. Now, in this case what happened actually, that your what we have to do is, so difference of this one with the previous one, I mean a lot of difference is there in the block diagram. Now, question is that when we are naming as a load following, that means for generator 1, those who will be in the load following, they need a load following controller, right. They need a load following controller. So, if you look into the diagram, this is actually unit 1 in area 1, this is whole is a area in area 1, that whole is a GENCO 1, right, and this is your unit 2, and area 2 this is unit 3 and this is unit 4, and same as the before that your previous case, the total disco 1, disco 2, disco 3, disco 4, how CPF is coming, right. Here that is not shown because that is understandable, right, but question is that thing your, in this case what happens, suppose first for the sake of understanding that each your what you call that unit must have one load following controller. So, this delta PGC1 is nothing but the contracted power demand. So, for example, for unit 1 I am writing it is, I am making it a delta PGC1, that is with unit 1 the contacted power demand. It is your what you call is distribution companies. There are 4, DISCO 1, DISCO 2, DISCO 3 and DISCO 4. So, they demand power say delta PL1, delta PL2, delta PL3 and delta PL4, right, and your contact participation factor you have. So, therefore, delta PGC1 will be your CPF11 same as before delta PL1, I am overwriting on it, then CPF12 delta PL2 plus CPF13 delta PL3 plus CPF14 delta PL4, right, delta PL4. So, this is actually delta PGC1 same as before, it is nothing but the delta P1 or delta PGC1, right. So, here it is making delta PGC1, right. So, this is my delta PGC1. So, same as before, but control structure here we need a load following controller. So, similarly for delta PG, just for your understanding writing everything, delta PGC2 will be CPF21, I am overwriting on it delta PL1 plus CPF22 delta PL2 plus CPF23 delta PL3 plus CPF24 delta PL4. That is nothing, this is the contacted demand by the unit 2 in area 1, right, because in area 1 1 GENCO, but 2 units, unit 1 and unit 2, right. So, this is for delta PGC2. Similarly, for delta PGC3 in area 2, so that is the contact demand. So, this one will be CPF31 delta PL1 plus CPF32 delta PL2, right, plus CPF33 delta PL3 plus CPF34 delta PL4. This is delta PGC3. Similarly, your delta PGC4, right, is equal to CPF41 delta PL1 plus CPF42 delta PL2 plus CPF43 delta PL3 plus CPF44 delta PL4, right. So, this is the contact, this is the power actually whatever contacts the various distribution companies they have the contract. So, each generating unit has to generate that much of power delta PGC1, delta PGC2, delta PGC3 and delta PGC4 for your your what you call by the your units unit 1, unit 2 in area 1 and unit 3 and unit 4 in area 2 respectively, right. So, that is why this delta PGC1 this is coming there, that delta P1, delta P2, delta P3, delta P4 it was going to the input, that is your turbine governor, that signal was going that this much power has to be generated. But here what we are doing is input is anywhere, nowhere here, nowhere here, input is nowhere here, right, nowhere, right, input is somewhere here we are giving. Now, question is that your this is delta PGC1, then here the delta PG1 feedback is here. So, these two are compared, that is your delta PGC1 minus delta PG1, this is the contacted one, and this delta PG1 that is generated by the your what you call by that generating unit 1, right. So, at steady state this delta PG1 it has to be is equal to delta PGC1, because this power has to be generated. For that what we are doing is we are putting a load following controller, that is Q1 upon S in our integral controller in this case. No PI or PID I have used, simply I have put an integral controller, right. So, that is then its gain is K1, right. Similarly, and feedback is coming here, it is coming here, right. That means, this generation that as we are taking this delta PG2 and this contactor is power demand, this controller is there, that means delta PG2 will chase delta PGC1, that is load following, right. So, it will steady state delta PG1 will be equal to delta PGC1, right, it will chase that this contacted power demand, right. Similarly, for unit 2 also you have a delta PGC2 and this is delta your PG2 and this is integral controller your K2 upon S. That means, that output, that is output is V1, output is V1. So, V1 is equal to actually K1 this integral this thing, then this is 1 upon S. So, integral controller. So, it is actually delta PGC1 minus delta PG1 actually dt, right. So, this is V1. So, that V1 is coming here as an input, right, or in general that Vi for ith unit is equal to Ki, that gain of ith unit, integral gain of that ith load following controller rather, right. Then integral of delta PGCi minus delta PGi dt, right. So, this actually this load following controller actually will force actually generation to match the contacted power demand at steady state. So, similarly here also controller is there, similarly here also controller is there, similarly here also load following controller is there, but there is no need that all the generating unit will everyone needs that it's load following controller, it depends on the system, right. Suppose this unit may have a load following controller, because suppose some discos have contact with that, and this unit maybe it has no contact with any discos, right. So, in that case this may not be in this thing, this will be in AGC. Now, another thing is that in this case, another thing that we have taken APF1 and APF2 AC participation factor, it is same as before, but as it is a load following. So, I have just changed this your what you call that term terminology, right. It was actually A-11 in the previous case, it is nothing but same thing APF1, that AC participation factor. Similarly, previous case A-12 it equal to APF actually it is 2, and APF1 and same as before APF1 plus APF2 it is actually 1.0, right. Similarly, for this case right. So, it is A-11 A-12. So, A-21 is nothing but your APF3, right. This is AC participation factor for unit 3, and similarly for this one A-22 is APF, that AC participation factor for unit 4. That means, here also same thing APF3 plus APF4 it has to be equal to 1.0, right. So, these are your what you call AC participation factor. So, basically this APF, this here also APF1, APF2 and APF3, APF4. So, basically your they have effect on the transient behavior of the responses, dynamic response, the responses, but it has no effect on the steady state as long as uncontacted power demand is not there. If it is there, it has effect, that we will see. Now, next one is same as before, this is delta p tie 1 to actual and this is delta p tie 1 to schedule, this feedback is given here. We have seen same as before, and this is delta p tie 1 to error. So, this is B1 delta F1 because this is delta F1. So, it is B1 delta F1, this is delta p tie 1 to error, and this is actually your AC1, right. Similarly, here also it is B2 delta F2 plus A1 to delta p tie 1 to error. So, this is actually your AC2, and this 2 as your what you call input to the integral controller. It is minus Ki1 upon S, this is minus Ki2 upon S, right. So, these two are your integral controller for this AGC, right. Now, and next for this block diagram, this delta PL1 local same as before. So, delta PL1 local is equal to nothing but delta PL1 plus delta PL2, that is your that is in area 1 you have two distribution companies, that is why their demand is delta PL1 and delta 2. So, delta PL1 local will be delta PL1 plus delta PL2. Similarly, for delta PL2 local is equal to delta PL3 plus delta PL4, right. This is in area 2, and if there is any uncontacted power demand, then in that case that it is delta PL1, you see that is uncontacted power demand in area 1. If apart from their contacted power demand, if any excess power demand needs by any distribution companies in area 1, that will be reflected in area 1, and it is expected that you have units, generating units in area 1, they have to supply this power, right, according to AC participation factor. Similarly, for area 2 also, that delta your what you call that your uncontacted power demand whatever it has to be supplied by the same generating unit in area 2, right. So, that means major difference is that this load following controller. So, load following controller. So, philosophy actually totally changed, right. Previous one was something and here it is something, but you do not need so many load following controller, because all the discos may not have contact with generating units in area, right. So, this is the your what you call that philosophy. Now, then so now this is whatever about the block diagram I explained. This is the figure 2 shows the block diagram representation of the two area system shown in figure 1, right. Figure 1 is schematic and figure 2 I explained to you. Now, each area is equipped with an AGC controller. So, each unit of the GENCOs is equipped with a load following controller, right. So, a demand signal, that is delta PGC1, that arrives directly from the load is compared with the power output of unit 1, that is delta PG1 I told you, to yield a mismatch, and this mismatch is given as an input to the reset controller, that is nothing but the load following controller, right. So, that will actually force the mismatch to 0, so that the generation follows the load. So, that is called load following. So, in figure 2 that I already explained, let me just little bit enlarge it. So, in figure 2 the inputs delta PL1 local and delta PL2 local are part of the power system model, but not part of AGC, that also we have explained before. Delta PL1 local is the total local demand in area 1, whereas delta PL2 local is the total local demand in area 2, that also I have explained to you, right. Diagram also everything block diagram I have explained, right. So, there is a possibility that uncontacted power demand, that a disco violates a contact by demanding more power than that specified in the contact, right. So, this excess power is not contracted out to any GENCO. This uncontacted power must be supplied by the GENCO in the same area as the disco that violates the contact, right. So, in figure 2 I told you delta PL1 uncontacted and delta PL2 uncontacted are the uncontacted power demand, that is UC, delta PL1 UC and delta PL2 UC are the uncontacted power demanded by discos in area 1 and area 2 respectively, right. So, in each area the ACE participation factor also I explained to you, right. Decide the distribution of uncontacted power in the steady state among various generating units, right. Next is the state space representation. So, the state space equivalent of figure this 2, it can be represented as x dot is equal to x, right, plus bu plus b dash v, because this v term is coming v1, v2, v3, v4 because of load following controller b dash, and gamma capital P and gamma dash p dash I have made it, this is equation 8, right. So, you have 5 terms on the right hand side a, b, b dash, gamma and gamma dash, and your what you call a x, bu, b dash v, gamma capital P and gamma dash capital P dash, right. So, you have 5 terms. So, where x is equal to the state variables. So, you have this your 2 generating units are there. So, 1, 2, 3, 4, this is actual, this is a delta p I 1 to actual, 4, 5, 6, 7, right, 8, 9, 10, 11. So, there are 11 state variables are there. So, state space matrix will be 11 into 11, right, and U there are 2 input, that 2 integral controllers are there for 2 areas. So, U1 and U2 this is transpose, this is all transpose it is given, right. So, next is V, there are 4 load following controllers in general. So, that is why V1, V2, V3 and V4 transpose, right, and P there are 4 distribution components, their power demanded are delta PL1, delta PL2, delta PL3 and delta PL4, and P dash that is uncontacted power demand, delta PL1 UC and delta PL2 UC transpose. In the previous case we took small p, but here I have taken P dash, right. The AGC integral control law for the ith area is given by that is UI, that is your AGC controller, minus KII integral of ACI dt, where KII is the integral gain of area I and ACI dt is the area controller of area I, right. So, integral control law for the load following for ith unit is given as, so Vj, it is actually, it will be jth unit, right. It is actually, it is not a, it is jth unit, because here it is written j, j, j and j. So, it will be your jth unit, right. So, it is actually Vj is equal to Kj integral of delta Pg Cj minus delta Pg j, right. So, this is a load following controller expression. So, now we will make some case studies, right. So, let us assume that unit 2 and unit 4 are under load following contact only. That means, in area 1, your area 1, that your unit 2 is there and area 2 unit 4 is there. So, these two are load following contact only. Unit 1 and unit 3 are for speed regulation purpose only, right. So, further no centralized supplementary control is available, that is Ki1 is equal to Ki2 is equal to 0. That means, in this diagram that is unit 2 and unit 4 under load following. That means, if we come back to this diagram once again, right, let me just make it to half, right. So, in this diagram, that your unit 2 and unit 4 are load following. That means, this is unit 2 and this is unit 4, these two will be in load following, and these two will be just under AGC, but that no supplementary controller. That means, this part will not be there, this part will not be there, and we will examine this case, because Ki1 and Ki2 are zeros, right. So, let me go back to that. Further, I told you no centralized supplementary controller is available, and all the discos have a total load demand of 0.005 per unit megawatt, right. Each which is 0.005 per unit megawatt each, which is contacted to the various generating units as per the DPM given in equation 16. So, this is actually disco participation matrix is taken. So, in this case that unit 2 and unit 4, they are actually in the load following. That means, discos have contact. Actually, this is your distribution company 1, I am putting D1, instead of discos it will take more space. This is D2, this is D3 and this is D4, right. This is D4 distribution disco 1, disco 2, disco 3, disco 4, and this is my unit 1. I am making it short. Unit 1, it is unit 2, it is unit 3 and it is unit 4, right. So, all are unit 3, unit 4. This is unit 1 and this is unit 2, unit 3 and unit 4, right. So, unit 1 and unit 3 are not under any load following. That is why they have no contact with any discos. That is why CPF is 0, this row is 0. Similarly, for unit 3, this row is 0, because it has no contact with any other areas, any other your what you call there your discos. So, the disco have no contact with them, here also nothing, but for unit 2 and unit 2 in area 1, because this is your area 1 and this is in area 2, because area 1 unit 2, area 2 unit 3 and unit 4, right, and their participation CPF is given like this, right, and their CPF is given like this, but if you add this it will be 1, 0.75, 0.25, if you add this it will be 1, if you add this it will be 1, and if you add this column wise it will be 1, right. So, this distribution participation matrix is taken, right. So, with this, thank you very much, we will be back again in the next.